Good everyone, welcome to MS tutorial. This time around, we're taking this aspect of mathematics called calculus. Earlier we've done something on limits of function. Okay, so this time around we're taking something on the gradient of function. So we also do something on derivative of function. What do we imply by the word derivative of function? We also take this aspect of differentiation, from first principle. So very quickly, let's touch this aspect of gradient of function. Alright, from this expression of gradients, let's check from this expression of gradients. This is n, that is n, which are going to be gradient, equals y2 minus y1 over x2 minus x1. So in this aspect now, let's say from this expression, okay, the moment we have, which is written as change in y or change in x, okay, what is one representing? So let's say we have change in x to be x2 minus x1. So obviously from this expression now, it implies that we can say that our x2 equals, if this come in, that's change in x plus x1. Okay, so this is actually one of the expressions such that in this case, okay, our change in x is not equal to 0. Okay, so since change in x is not equal to 0, we can equally see that our x2, okay, which is the other value equals to what? X plus 1 plus change in x. Okay, so let us try to take this aspect. And initially, from the original expression, also from this expression, we can also recall that our y1, okay, that is our y1, will obviously be the original function. Okay, let's say our y gives us the original function. Therefore, in this case, change in y, okay, which is the second value of y, which is the one we have here, then will obviously be that is f will be equals to x1 plus change in what? In x. Okay, I'm sure we can recall that I'll say that these are our x2, then the change in x with x1 from the expression that we derived earlier. So from here, what does this imply? You can then see that our change, that is the gradient, okay, then equals to y2 minus y1, okay, over x2 minus x1. So which is synonymous to saying that the expression will also give us, okay, this is y to f like this, okay, minus what's our y1 from the expression? That's the actual function over this will just give us what? Dx. So the expression we have here, okay, is actually representing this n, that is gradient, okay, which is expressed as this expression, okay, that is the initial change in x with so from here, okay, we have the actual expression for what? For differentiation in a very simple term. Okay, it is in a very simple term. So this one gives us the expression in a very simple term. So therefore, you all can agree with me that our gradient, that is n in the gradient, okay, then equals to y2 minus y1 over x2 minus x1, which is synonymous to what? Change in y over change in x, which you can call dy dx, okay, being equals to f of function x plus that's x1 dx minus the original function over everything we take, okay, as dx. So in this case, you don't forget that this one also is actually the original expression, okay, for the function that is given, okay, which is usually equals to your y. You should recall that y equals to what? F of x. Let's say the situation by giving this expression, let's say 2x squared plus x plus 3. Okay. This expression now, okay, y is equals to this. And what we have here, okay, is usually what we have here. So sometimes you can take this and sometimes you can also. So most important thing, you should not forget that this is not the expression for what? For gradient. This is essentially a start of the expression for differentiation. So very quickly, let us go to the second aspect. Now, so this aspect now talks about the derivative of function. Now, how do we express derivative of function? Okay, in mathematics, it's always very, very important to get this aspect done, because sometimes it will actually help us to be able to minimize some problem. Okay, so let's take this aspect. It's very, very important. And further math students, physics students, chemistry students, and the rest. This part is very, very important. So let's take this. Now, from our gradient formula, we know that y, okay, is equals to any function that we have. Okay. So in this aspect now, notice one thing. This aspect, as y increases, s increases. So let's check this part now. Okay. So y is equals to f of x. So in this case here, let's say we have this particular graph. And remember, we want to get the gradient of this line here. Let's say this point is from x1, and then we have x2. Okay. As long as that is the then we have y1, and then we have y2. So the first way to calculate gradient, we know that the implication here, okay, is that as y increases, okay, as y increases, s also does not increase. So as both of them are increasing, first we have to get the gradient. Here we have change in what? In y, so change in x. So in this case here, for us to be able to have gradient, that means x must increase and y must also increase. So all we just need to do here, as first, is to do what? Is to take the increase in y. You see, let y increase. Okay, and as y increase as well, x will also do what? X will also increase. So as both of them increase, then you can easily simplify and do it. So from here, let's substitute everything we have here in what we have here. So this one is to y plus, so this is y changing y. Okay. So yeah, changing y, because what our then do, x change to what? X plus change in x, without adding any identity. So let's just express this now. Now, since we are trying to find the derivative of function given what? The y on dx. Okay. This is what we want to try to express now. So, trying to express that, what are we going to have? This has to come to this side to give us y equals f of x, change in x, minus the y. Okay, minus the y. And so this has to be the y. Y has to come to this side. Okay, so let's correct that very quickly. So from here, what we need to do, remember that our y is equals to f of x from the onset. Okay? So if y is equals to f of x from the onset, we can equally have the y equals f into bracket x plus change in x. What's our y? Let's substitute our y back. That will be minus f of x. Okay. And remember, the expression we are looking for is what? Is the y on dx. So what do we do? So the next thing we do now is to what? Divide through by dx. So what does this become? The y on the x equals f of x plus the x minus f of x, okay, all over dx. So the next thing we need to do after this, after getting this this expression of is that we should be able to limit this dx to 0. So when we limit dx to 0, then we get the derivative of the function. So let's do that. So all we need to do now is that first now have this smaller expression, okay. That means that we have to limit dx to 0 in everything we are doing. That is, in this case, we have to limit these are dx, okay. These are dx, we limit it to 0. And the moment you limit dx to 0, then we can have everything we have in this expression equals to this, okay. So the moment we limit dx to 0 along the expression, then we have everything we have equals to so our dy dx, okay. Our dy dx is then equals to everything, this is dx limited to 0. So that's how the expression is gotten. Okay. So that's how this expression is gotten. So without wasting time, let's quickly check some example on derivative of function, okay. This aspect, we try to focus more on 3 key aspects, that is y, okay, y, normally you know that y and this, okay, a bit of liquid, okay, something like that. So let's try to take one question. Using differentiation from the first term principle, okay. So let's take this example. So we want to try to differentiate 1 equals to x2 using first term principle. So don't forget that in this case here, okay, we can imply that y equals f of x, okay, so something like that, x2. Okay, but this one I'm going to start from y equals x2. So let us call this one star 1, okay, let's call this star 1. So now there are 3 different stages which we are going to cross, okay. 3 different stages which are going to cross. So the first stage is the stage we are calling the substitution stage, okay. Then the next one is the subtraction stage, and along the subtraction stage I'm going to do a kind of expansion, a little bit of expansion, okay. Then the aspects where we have to limit the x, the way we have to do that limiting of the x to 0. So let's take that as now. So now for the substitution tip, now there's something you need to know, okay. The graph we drew earlier, do you get that now? This particular expression, okay. But I said that for you to find the ingredient, let's say this piece is 1, 2, okay, and then 1, 1, okay. So corresponding value will be this one. As y increases, okay, x also increases. So what we're doing now is that anywhere we see y, we're going to substitute y plus the y. Also, anywhere we see x, we're going to substitute x plus dx. Okay. So let's do that in this equation. So in 1, we're going to substitute these 2 in equation 1. We substitute in this. Let's call this star 1. Okay. So here, y equals x squared, that will change to what? Y dy. Okay. So let me move this now. This will change to this. Okay. Y anyway is x. So y will change to y plus dy. Okay. dx squared. So taking the expansion of this now, by taking the expansion, our y plus dy remain. When we take the expansion of this, what happened now? That was x plus dx with x plus dx. So if they expand this, okay, what am I gonna get? On this side here, we get x squared plus dx again. This time this is x squared, and this times this gives us x dx. This time this gives us x dx, and this time this gives us dx squared. Okay, so that's what we're gonna have there. On this part, that's the x squared there. So let's switch the expression. But this is the x squared. So if I bring this together, okay, what I have here, then give me x squared plus 2x dx plus dx all squared. That's all squared. So here we have 1, on this side we have 1 plus the 1. We have 1 plus the 1 on this side here. Okay, so now the next thing to do now is, after we have to do like a subtraction step. So y can come to this side. So we have the y left on this side here. So when this y come to this side, what do you have on this side? We have the y equals x squared plus 2x dx plus all bracket dx squared minus 1. Okay. Now the substitution stage now, okay, which I'm talking about, which I spoke about then. Remember this stage, right? Says after the substitution, we go to the subtraction stage. Okay, that subtraction stage is what I'm talking about here. This particular point here, where we have to subtract. But remember, from the original expression, okay, our y in this part here, okay, this y equals to f of x and equals to, which is what we have here. Okay, so that means that this time around now, I'll substitute my y equals to x squared in this part here. Okay, so what do I have then? What am I going to have then now? That will be the y equals x squared plus 2x dx plus dx squared minus x squared. So which means that in this case here, this is minus x squared here. Take care of this x squared. So what do I have left down here? As I this down part, I have the y equals 2x plus dx plus dx all squared. Then the next thing to do, remember that our major aim, okay, from the start is to find what dy dx. Okay, that's it, to find dy dx. Okay, that's our major aim. So what do I do here now? What do I do? You divide through by what? X. Divide both sides by dx. So now recall that the expression we have for here now is after this has been removed. Okay, x minus plus x squared and x squared. What we have left is 2x dx plus this. Okay, so the next thing we need to do is to divide both sides by what? By dx. So taking it from here now, okay, divide through by, so here will be dx on dx on dx. From here, just take care of this. One of them considers it. So from here we have the y on dx equals to 2x plus dx. So now the next thing we need to do now in this part here is to limit this dx to 0. Okay, when we limit dx to 0, what are we going to have? Okay, so in this case here, what we have now is that our dy dx, then when we want limit dx to 0 in 2x plus dx. Do you get that now? I know this one is the same thing as our limit dx to 0. Here will be 2x. Then on this side, then we have plus limit dx 0 is dx. In this case here, this is the expression we are limiting to 0. We don't have dx here, but here we have dx here. So that means that in this case here, we have 0, we have 2x, y dx here returns towards 0. So therefore, our dy, okay, our dy dx equals to dy, finally dx equals to 2x. Okay, so this is our final answer for this expression. So let's see this simple question. Okay, using the first principle, we want to differentiate 2x squared minus 5. So let's get into the solution very quickly. So still using the same step. Don't forget that the first one is substitution. Then we go to subtraction. Then the limiting stage. Okay. First substitute. Then go to the subtraction stage. Then finally the limiting stage before we have the final answer. We have to be very, very careful. So recall that we can say y is equals to 2x squared minus 5. Okay. Then let's call this one 1 star. Okay. So don't forget that as y increases, x also increases. So we can say that let's put our x to be x plus 1 dx and our y to be y dy. Okay. So we're going to substitute wherever we see y, this will come, wherever we see x, this will come. So what I'm going to have now, okay, as at the substitution stage, do you get that now? As at the substitution stage, okay. So what do we have? Y equals 2x squared minus 5, which means everywhere you see y, we put this, that becomes y plus dy equals, in this case 2. Anywhere we see x, it becomes this. So we have 2 into bracket x plus dx. I know from the question here we have square minus 5. So we have to do a bigger expansion here. Alright, so let's check back. Let's check back now. Don't forget that f of x equals to this. That's equals to 2x squared minus 5. So put y equals to 2x squared minus 5. Let's put down this star 1. Then as y increases, x increases. So from here, we have x equals to this. So anywhere we see x, we put this. Anywhere we see y in this expression, this particular expression now. Okay? This particular expression. So anywhere we see y. So that's what I'm trying to do here. Okay? So now our y changes to this, then our x changes to this, and remember there's this square. So we have expansion to go on this side. So this will remain y plus the y, because if we expand this will become x squared plus 2x dx plus open bracket dx squared minus 5. So that's what we have there. So which means that this part we still have to multiply through by 2. So when we multiply through by 2, what do we have? We have y plus y equals, open this bracket, this becomes 2x squared plus 4x dx plus 2 into bracket dx squared minus 5. So the next thing now, okay, we want the y to remain on this side. So this y has to come to this side. So what do we have there? We have our dy equals 2x squared plus 4x dx plus 2 into bracket dx squared minus 5. Then if this y come to this side, it becomes what? Minus y. So the next thing now, recall that from the original expression, y equals what? 2x squared minus 5. So that's not going to substitute as for y now. So what I'm going to have now, that will be dx equals y. So that will be dy equals 2x squared plus 4x dx plus 2 into bracket dx all squared minus 5. Then this becomes this now. What we have here. So that becomes minus, since that will be minus 2x squared minus 5 close the bracket. So if I write out the expansion now, if I order the y will be equals to 2x squared plus 4x dx plus 2 into bracket dx squared minus 5 minus times given plus that will be minus 2x squared. The minus and the minus will be plus 5. Now let us see. I have 2x squared here. Okay, this is 2x squared. So this 2x squared minus 2x squared is out. Plus 5 minus 5 too is out. So what we have left, we have y equals 4x dx plus 2 into bracket dx all squared. Okay, since this has taken care of this, the minus 5 has been, what you have left, we have dy equals 4x dx plus 2x. So this is the other expression that is this and this. So the next thing we need to do now is to do what? Is to divide through by what? By dx. So let's try to divide through by dx. So dividing through by dx. What do we have? The y dx is equals to 4x this plus 2x plus 2 dx all squared. Then everything I have there to divide by what? Dx. We have one dx here, we also have a dx here. Okay. So from what we have here now, okay. If I try to split this, okay, that's 4x dx on dx plus 2 dx on dx and we know that it's square. So this one take care of this, then this also take care of all of this. So what I have here still be 4x plus what I have here 2x 2 dx. So the next thing to do now is to limit dx to 0 here to have our normal dy, that is dy on dx. So in this case here, if I limit what dx to 0 in this case here, okay. So what I'm gonna have now will be 4x dx to 0 plus dx to 0 is 2 dx. Okay, so let's try to limit in this case here, when I split it, when I write out, that's mean dx to 0 4x plus mean dx to 0 on 2 dx. So there's no dx here, but there's dx here. So what do we have then? Right now, dy dx is dy dx is equal to, there's no dx here. So from here, this becomes 4x, and obviously we have this expression here to be 0. So finally the answer will be 4. So here, the y on dx is equals to 4x. So our dy dx is equals to 4x. So that's our final answer. Alright, let's check this particular question. Okay. Using our first principle, let's try to find the derivative of this expression. Don't forget that as y increases, x also increases. So here we have y, same thing y equals to, let's call this one star. Okay. So y returns what? Y plus dy, then x returns what? X plus what? Dx. Okay, very simple. So the next thing we do now is to do our normal substitution. Okay, in this case, wherever I see y, I put this. Wherever I see x, I put this. So what I have now, y equals to 1 over x returns to y plus dy. Then I'll have 1 over x plus dx. Okay, that is at the substitution stage. Don't forget the 3 stages. Okay, substitution, the subtraction, okay, and the last thing, the limiting stage. These are the 3 most important stages that you need to know by heart. The substitution, the subtraction, and the limiting stage. So from here now, what do I have from here now? Okay, what do I have from here? So right from here, you see, in this case, we don't have much expansion to do. So I can just bring my y to this side. So from here, my dy will be equals to 1 over x dx minus y. Okay. So what I have here now? Then equals to y over x. So let's substitute this for this. Okay, from this expression, y. So we are substituting this one for this one. Let's substitute one. That becomes 1 over 1 over x. Okay. So now these two expressions. Okay, what I've done is that I've substituted this one for y equals to 1 over x from the original question. Okay. When substitute y equals to, this is what we have. So in this case now, we need to find the LCM of this and this. What will be the LCM? Okay. LCM of x and dx and x will be, we take the two together. Do you get that now? That's when we just take the two together. What will be the LCM? The LCM will be x dx and x. So it's only the two of them we have. Okay. Dy from here now, and dy will then be equals to, taking the LCM of this, that's x dx, okay, that's x dx with x. Okay, so this over this, x will be left, so I have x. Then on one side I have minus, then this over everything I have here, this will be left, I'll be left with x plus dx. So let me simplify this one further. Let's simplify this one further now. If I expand it, I have x. This time this will be minus x. This time this will be minus dx all over x dx equal to x. Okay. So further on, dy will be equals this one and this one, that's 0. What I have up left, that's the x over. So this time this will give me x squared. Why this time this will give me x dx? I open this bracket here. Why this one? I simplify this one. So in this case now. So the next thing to do now is to divide. Okay, is to divide through. Now this time now that I want to divide both sides by dx. Okay. How am I going to go about that? Okay. If I divide both sides by dx, obviously this one and they're together. So let's divide by dx and also divide this side by what? By dx. Okay. I know many of you will be asking, now why did I just put yes? This is very correct. Okay. Because in an expression, let's say this one is a, and everything I have down here, okay, is b. Okay. So I have a over b, and I'm still dividing by what? By dx. Okay, I'm still dividing by dx. These are together. To write the correct expression of this one now, this is what? A over b times 1 over dx. So what do I get here? Everything I have up here, we represent a remains over b times what? Times dx. So this remain, then dx come to the side. So that expression is already close. So I'll try to remove it up now. Okay. So don't forget. So let's continue solving this one. So now I can remove this just for explanation. So for me, this is dx of dx down. So this dx can take care of this dx. This means I have one left of it. So the next one I have is dy of x equals minus 1 all over x squared plus x dx. So that's what I have in this part here. So for me, I can decide I want to, I can just try and leave this like this. So the next thing to do now is to find out what a normal, a minimal change, which is the one of dx. So to get that, now I have to limit, this dx to 0. So I have minus 1 all over x squared plus x dx on this side here. Okay. So that means this dx has to be limited towards 2. So we limit to 0. What are we going to have? We're going to limit this only the dx here to 0. That means that our dy and dx will then give us minus 1 all over x squared. This expression will become what? 0. So here I have minus 1 on x squared. So what we have here is our final answer. Final answer dy dx equals to minus 1 over x squared. That's our answer using first principle. Right now, let's say this aspect. Okay, let's talk about derivative of something. Let's say you are given a function, okay, and in that function now, okay, and in that function, okay, we discover that we have, mixed up, let's say sum or difference of expression. Normally, you have like sum for these ones. So what do you do? Very, very simple. Let's take some example very quickly on this. So what do we have to express it? Okay, if f of x is given u of x, your dy dx will be the first one differentiation normally, the second one differentiation normally. Now the expression we need to use here, okay, the expression we need to use here is that let's say you are given y, okay, equals to x raised to the power what n. So your dy, okay, on dx, dy dx will be what you have here, which is the power, multiply by the power first, okay, then x will be what you have as the power, subtract 1 from it. So that's how you take the expression, okay, of so we're going to make use of this expression. We'll multiply by the power, subtract 1 from the power. That will give the derivative of sum from each of the expression you differentiate. So very quickly, let us check for this example, okay, using the derivative of some expression. So from there, for one, I have so don't forget the expression. If I have y equals x raised to the power n, okay, my dy dx will be multiplied by n, then subtract 1 from n. So that's what we're going to use for all these constants. So the first one, what the first one says, y equals 2x squared plus 5. Okay. So what do you do? Let's put this on my dy dx equals to multiply this by the power, that will be 2 times 3. Okay, then subtract 1 from what from here. That will be 2 minus 1. Plus now anytime what we have here, this expression here, it's called the constant. Okay, anytime you express a constant, okay, you find the derivative of a constant, it's usually equals to what? Equals to 0. So here we have 0 for this one. So finally what we have here, 2 times 3 is 6. Then this gives what? 2 minus 1. That's 1. So that means that dy dx will be equals to what? 6x for this expression. So that's the answer to the first one. Okay, 6s. So for the second question, this is 2x squared minus 6x plus 1. Let us find the derivative. We are taking this one first. Okay. So that will be multiply by the power. Remember there's 2 here, so multiply by 2. Then take x, subtract 1 from the power. Okay. The second one we have minus. What that will be 6. That will be 6 times the power of x will always be 1. So 6 times 1, then it's x. I have a power of 1, and 1 minus 1, that will be 0. Y constant plus 1, that's a constant. Okay, that will be equals to what? 0. So what that will be? 2 times 2 will be what? 4. 2 minus 1, so here you have x to the power 1. 2 times 2 is 4. 2 minus 1 and for the power, that's 1. Minus 6 times 1 is 6. Okay, 1 minus 1, that's 0. So I have x to the power 0 plus 0 here. So the final answer for this particular expression, okay, will give us the y into x equals to 4x minus x to the power 0 is 1. 6 to the power 1. 0 again. So for them we have 4x, okay, minus 6. So that's the answer to this, okay, to this expression. The answer here gives us 4x minus 6 here. That's the answer. So let's take the next question also. So the next question says y equals to root x. Okay. You know, for this one, this particular text, I can write the text as x to the power 1 over 2. Okay, from law of indices, so that y equals to x to the power 1 over 2. So therefore, what do I do for the power? Subtraction from the power multiplied by the power. So from here, my y dx will then be equals to x to the power 1 over 2 minus 1. Then I'll multiply by what? 1 over 2. So that will be multiply by 1 over 2. Okay. Then subtract 1 from 1 over 2. So what that will be to be the expression now? Okay. That will be 1 over 2 times x. What I have up here, okay, that will be 1. Let's make this 1 over 1. Okay. So sm of 2 and 1 is 2 into 2 is 1, 1 times 1 is 1, then 1 into 2 is 2. So what I have is 1 over 2 times x. 1 minus 2 is minus 1. All over what? All over 2 for the power. So finally, what I have is that I'm having x, okay, as 1 over 2, okay, times x is the power of 1 over 2. And you know, if I have minus here, from law of indices, okay, your 1 over a is something as a is the power minus 1. So since I'm having 1 over 2 as the power, I can write it as what? I can write it as this 1 over 2 times 1 over x is the power 1 over 2. So this thing like the y, the x, the y, the x, the y, the x. So finally, what we answer? This time this is going to be 1 over 2 over x is the power 1 over 2. So simply as 1 over, I can write this one, since this is 1 over 2, I can still write that 2 root x. So from here, my dy dx equals 1 over 2 root x. Okay, so that will be our answer. So let's take the next question too. So now let's look at this. Let's look at this aspect now. Okay. As first, I cannot simplify this one easily. I have to just split it first. Okay. So our y equals x to the power 3 over x plus 3x over x minus 1 over x. So for me, this becomes y equals, this one will be x squared plus x taken with x here. That will be 3 minus 1 over x. So for me now, I can still write this as y equals x squared plus 3 minus x to the power minus 1. Okay. So for me, I can then manipulate my dy from dx. So for me now, dy dx will then be equals to multiply by the power. Okay. Then subtract 1 from the power. That's 2 minus 1. Look, this constant here will change towards 0. So it's a constant. Okay, there's no x there, so that's a constant. Then minus, what do I have? Multiply by the power, that's minus 1 times subtract 1 from the power. That will be minus 1. So that minus 1, that will be minus 1 minus 1. Okay, so here now, what do I have here? What do I have here now? This becomes, this one turns to be minus y and x equals 2x raised to the power 2 minus 1, that's 1. Then 0, then this becomes minus. Okay, what are we going to do? Minus x minus 1 minus 1 is minus 2. Okay, so on this side I will having 2x minus times minus is also plus, so 0 will be out. Okay, 0 will be out. That will be minus. Okay, that will be plus. Minus times minus is plus. Okay, so that will be x raised to the power minus 2. So I can have my final answer. So this is x raised to the power. So this is what I've done here. This is 2x, 2 minus 1, 0. Then from what I have here, this is minus. Multiply by minus 1. Subtract 1 from, that's x raised to the power minus 1. Subtract 1 from the power minus 1. So if you come down, this becomes 2x. This is x, 2 minus 1. Subtract 1 from the power. 2 minus 1 is 1. This is 0. This one is minus minus. Minus minus is because of plus, obviously. So minus 1 minus 1 is minus 2. So here I have 2x. This is 0. 0 is out. Minus times minus is plus. Then from here, remember this is minus 1 minus 1 equals minus 2. Okay. So we have minus 2. So finally our answer, the y and the x will give us 2x plus. Okay. This one here. Okay. I have x minus 2. X raised to the power minus 2. So I can change x raised to the power minus 2 to 1 over x raised to the power 2. Okay. So I can have it as 1 over x raised to the power 2. So this is our final answer for this particular question. So let's check this question too. Okay. So this one I can write this as y equals to, this is a very question now. We have to simplify this again. So this is example 5. So now I can write this one as x raised to the power 1 over 2. Yes, this one I can write this as okay. If I have, let's say I have 1 over with x, I can write it as with x raised to the power minus 1, and this one is the same thing as x raised to the power 1 over 2. So times minus 1. Okay. And this one is times minus 1. I can write it as x raised to the power minus 1 over 2. Okay. So this one I can write as x raised to the power minus 1 over 2 minus 5. Obviously constant is equals to 0. So I have this one to do. So my dy, the x, what does the rule say? Multiply by the power, subtract 1 from the power. So let's take this one easy. I multiply by 1 over 2. Okay. Subtract 1 from the power, which is this. So that one is done. This one here will multiply by 1 minus 1 over 2. Subtract 1. Okay. From minus 1 over 2. And obviously, you know our constant here will be what? 0. Constant is equals to 0. So this is the question we are solving. So let's use example. Y and x. Okay. Let me come a closer so you can see at this point here. This will be 1 over 2 times x. From here, let's just do 2 times 1, that's 2. To make this, so that will be 1 minus 2 times 1 is minus 2 all over 2. Down is done there. Plus, here is minus 1 over 2 times. Remember, we are supposed to subtract 1 from here. Okay, so let's subtract 1 from here. So here, 2 times minus 1. Okay, that will give me minus 1 over 2 minus 1 minus 2. okay, to make it a simple expression. So furthermore, the y dx will be equals to, further now, this will be 1 over 2 times x. 1 minus 2 is minus 1 over 2 for the power, okay, plus okay, I have minus 1 over 2. Yes, so I'm having times x. 1 minus 1, that's minus 3 over 2 for the power then. Okay, so let's do it simply. So the y on the x, okay, the y dx will be equals to, yeah, we'll be having 1 over 2 times, I have minus 1 here, so this one can change to 1 over x is to the power 1 over 2. Due to this minus 1, so to get that. So plus, I can bring out this minus now, so this one become minus, okay, open brackets 1 over 2 times, I have minus here too, okay. So this minus you can make it into 1 over x is to the power 3 over 2. Okay, so that's all I have on that part. So that's where we stop there now. So let's continue from there now. So if we continue from there, what do you have now? This one I will change to, I can change this one to 1 over 2 and 1 over with x. So this is raised to the power 1 over 2. Okay. Minus, open bracket. This one here, again, 1 over 2. What I'm having up here is 3 over 2. That means that I'm taking square root of 2 and power of 3 from law of indices. Okay. So that's it. If I have x raised to the power a over c, what this one will translate to? Okay. If I'm having x raised to the power a and c, what will translate to be? This one now will be the nth root with c. Then a will now be what? The power. Okay. So here I can say that's what I have at the bottom of the third root of x for this power. That will be third root of x, so it's the power of 2. Okay. So that's what we have there. So we're almost done. Then what we have here now, then give us 1 over 2 times this will give us 2 with x minus this time this will then give us 1 over 2 third root of what? Of x squared. So that's what we have there. So that's our y dx. So the y dx give us this for this particular question. And synonymously, you can also see that since 2 is common, we can try to factor out and say the y dx equals to 1 over 2 close brackets 1 over x minus 1 over third root of what? Of x squared. Either way, this is our answer. So everyone took their precious time to watch this part of calculus, that is differentiation using first principle and using finding the derivative of what? Of some of expression relating to calculus, that is differentiation. So let us watch out for the other parts, okay, which we have to deal with the other aspect of differentiation. So thank you once again. This is MS tutorial. Love you all. Let's keep watching and let's keep sharing. Thanks. See you in the next video.